our next unit is, or our next part of our unit is going to be on more complex circuits. So they're going to be a combination of series and parallel, all in one circuit. When we're solving these, the steps we're going to take are pretty much the same. We're generally going to try to find the R total. So step one is going to be to find R total. We're going to have to use both the series rules where the R's add and the parallel rule with the reciprocals to find the total resistance. Then we're usually going to find I total. We're going to do that by using V equals IR. And then we have to go back to our basics. Our basic rules are the loop rule and the junction rule. All right, so here's our first example of a more complex circuit. We're going to find V, I, R, and P for each resistor. So I'm going to make a chart to keep track of things because I think it makes life easier. So V, I, R, P, and then total. And this time I have three resistors. I'm going to call this one resistor 1, that one resistor 2, and that one resistor 3. So 1, 2, and 3. And I'll build my chart. Okay, so our first step was to find the total resistance. And for this one, I have this resistor 1 is in series with this parallel combination. So I'm going to figure out what this is equivalent to first, this parallel combination. So I'm going to do 1 over R. I'm going to make a little parallel so I know what I'm doing, or maybe label it P. 1 over R parallel equals 1 over 12 plus 1 over 8. And the common denominator for that would be 24. So this gives me 2 over 24 plus 3 over 24 gives me a total of 5 over 24. Now remember, that's not our resistance, that's 1 over the resistance or the reciprocal. So the parallel part, RP, is going to be 24 over 5. And if we divide that out, we're going to get 4.8 for the parallel part. So what we found is that this is equivalent to a single 4.8 ohm resistor. These two together, their equivalent resistance is 4.8. Now that 4.8 is in series with this 4, and for series I just add them. So my R total is just going to be 4 plus 4.8, which gives me a value of 8.8. So I can put that in for my R total. Now I am going to take and put in my givens now. So I was given that the total voltage is 12, and R1 was 4, R2 was 12, and R3 was 8. Now our second step said to find I total, and I can do that using V equals IR. So V equals IR. So I'm going to put 12 volts for my total voltage equals I times 8.8. To solve for I would divide by the 8.8, and I end up with a current of 1.36 amps. So I'm going to put that in here for I total, 1.36. Now here's the trick to this. I now know that there's 1.36 coming out of the battery, because that's the total. And you notice there's no junction before I get to resistor 1. So that entire 1.36 is going to go through resistor 1. So now I know this is going to be 1.36. And now that allows me to find V1 by doing V equals IR again. So maybe make this blue. So V equals IR. So that's going to equal 1.36 times the resistance there is 4. And that's going to give me a value of V equals 5.45 volts. So I can put that in here for V1, 5.45. Now, if I look at my this junction here, okay, I got 1.36 traveling through this resistor, 1.36 gets to there, and then it splits into I2 and I3. And I don't know what either one of those is going to be. I can make a guess that the current through the 8 ohm resistor is going to be greater than the 4 ohm resistor, because it's less resistant to have greater current, but I don't know what each of them is. I know they have to add to the 1.36. So my junction rule isn't helping me at this point. So I'm going to do a loop rule. I'm going to make a note up here that my voltage for this one is 5.45. Then I'm going to go around the left loop. So if I go around the left loop, I gain 12 in the battery. And then I have to lose the rest by the time I get back to the negative side of the battery. So I gain 12 going through to the positive side of the battery. I'm going to lose 5.45 here. And then I have to lose the rest of it when I go through this second one. And when I do the left loop, that's all there is. I'm not going through resistor 3. So then I can find the voltage to the left loop just by doing 12 divided by 5.45. And I get the voltage 2 is equal to 6.55. So now I can put 6.55 here. Okay. Now that allows me to find the current here. So I can do V equals IR to get that. So V equals IR. So 6.55 equals I times 12. And if I divide by 12, I end up with a current of 0.55. So we'll put that in here. All right, now we're almost done. Okay, there's a couple ways I can go from here. I'm going to do it this way. I now know there's 1.36 coming here. There's 0.55 going down here. And then I'm trying to find this current here. Well, I know that I have 1.36 going into the junction. I got 0.55 coming out here. So the remainder has to be flowing this way. So if I want to find I3, I can just do 1.36 minus 0.55, and that gives me a value of 0.82. Must be some rounding in there, so 0.82. Now if I do 8 times 0.82 to get the voltage up here, because V equals I times R, I will get a value of 6.55. Or close to it. There's differences in rounding here. But it matches this voltage over here. The reason why I know that has to be true is if I do my outside loop, I gain 12 in the battery, and I lose 5.45 here. Now, if I take the outside loop, the only resistor I'm going through is this one. Okay, R3. So the remainder of the voltage has to be lost there. So the equation would look just like the equation for the left loop. Okay, because I gain the same 12 through the battery, I lose the same 5.45 through resistor 1, okay, and then so V3 would be the same as V2. Also, they're in parallel, and our parallel rule says the V's have to be the same. Our last step might be finding the power, and to find the power, we're going to do P equals VI. So I would take the voltage of 12, multiply it by 1.36, and that's going to give me a value of, it gives me a value of 16.32. Now, if I multiply each of these V's times the I's, I will get the power for each one. And I've done that, and I found I got a value of 7.41, 3.6, and 5.37. Now, there are some rounding errors, but the powers all have to add. So if you add the 7.41 plus 3.6 plus 5.37, you'll get about 16.32. So that's a check. Okay, we have one more example. So this is another complex circuit because I have a parallel element to it and a series element to it. In this case, these two are in series with one another, and then they're both in parallel with this one. So I'm going to take care of the series part first. So I'm going to make up my chart to start with. I'm not going to bother with power this time. V, I, R, total, 1, 2, and 3. Make sure I remember that this one is we'll call 1, this one we'll call 2, this one we will call 3. My chart. Like so, I'll put in my given, so I have 120 volts for the total voltage, 24 ohms for the first resistor, 9 ohms for the second, and 3 for the third. This time, I'm going to take care of this series part first. And for series, you just add. So R for the series part is just going to be 9 plus 3 equals 12. So these two together are equivalent to a 12, and then that 12 is in parallel with this 24. So I use my parallel rule, my 1 over R total equals 1 over 24 plus 1 over 12. Our common denominator is going to be 24, so it's 1 over 24 plus 2 over 24 is 3 over 24. That's the reciprocal of the total resistance, so our R total is going to be 24 over 3. And this one works out nicely. That's going to give me a total resistance of 8. So I'm going to put the 8 in here. Now, pretty obvious, our next step is going to be to find this I total using V equals IR. So 120 equals I times 8, and that's going to give me a current of 15 amps. So I'm going to put 15 in here. Now this one's going to be different than our last one because the 15 amps is going to come out of the battery and go down this wire. But then it's going to split at this point before it gets to resistor 1 or resistor 2. So in the last one I could fill out this I1, but I can't do that for this one. So I can't use a junction rule, so I'll do a loop rule. And again, I'm going to look at the left loop first. So for our left loop, okay, we gain 120 in the battery and then lose it all just in the one resistor because there's only the one resistor there. So that just tells me that V1 equals 120. So that was actually very easy. So this is going to be 120. And shall be able to guess our next step now is going to be to find the current through this first resistor. So we're going to find I1. we're going to find the current down through here. All right, so we'll do V equals IR. We get 120 equals I times 24. And that's going to give us a value for the current of 5 amps. So this guy here is going to be 5 amps. Now if I label it, this is 5, it should be pretty obvious what the current in this branch is going to be. Because I have 15 coming into this junction, I have 5 going down through this branch, so the other 10 has to go this way. So I here is going to be 10. And then that 10 is going to continue through this resistor and then go down through this resistor. So both of these are going to be 10. And then to finish off, we can do V equals I times R. So 10 times 9 gives me 90. And 10 times 3 gives me 30. Now you'll notice those add up. 30 plus 90 equals 120. And if I check myself by doing the outside loop, I gain 120 here. By the time I get back, I have to lose all 120. So I gain 120, I lose 90 here, then I lose another 30 here, I lost a total of 120. It checks out.